Hi everyone, once again welcome back to our class. Last class we were discussing about the constraint motion, different cases, find out the accelerations of those bodies in terms of masses. Now we were discussing about the constraint motions, find out the velocity of the blocks and acceleration of the blocks, different process. Okay, now first of all, statement here, power. What is the power? The statement of the power here, first of all, the power is a scalar quantity, the product of force vector and velocity vector, that is equal to here power. So power is a scalar quantity. First of all, here listen, power statement, power is equal to force into force vector into velocity vector, that is equal to here P is equal to F bar dot V bar, force vector and velocity vector. This, okay, this is the power. Power is equal to here F V cos theta, F V cos theta. This is the power formula. This is a power formula. Here theta is a angle between force and velocity, force and here velocity. Okay, here for example, if theta is equal to 0 degrees, the power is maximum. Power is here maximum, power maximum here positive. This is a positive, that means here P is equal to FV. Yeah, theta is equal to 0 degrees. If here theta is equal to 180 degrees, theta is equal to 180 degrees, so cos 180 is equal to here minus 1. So the angle between force and velocity here 180 degrees, that means here velocity and force both are in opposite direction, both are in here opposite direction, that is equal to here maximum power, but power is here negative. In this case here P is equal to minus FV. Here minus symbol indicates force and velocity both are in opposite direction. Okay, this is a power formula. Here we will discuss about the constraint motion. Here force nothing but here tension in the string, so power formula P is equal to FV cos theta, that is equal to here F is equal to T means here tension. Yeah, T means here tension force, tension in the string, so TV cos theta, TV cos, this is the power. Here scalar, it is a scalar. Dimensions formula here, dimension formula, for example, m l square T inverse of minus 3. This is a dimension formula, it is a scalar quantity. SI units of power is equal to watt or joule per second, joule per second. Now we were using this formula in constraint motion. Okay, here power is equal to this formula, very important, we explained in constraint motion. Now here power formula P is equal to FV cos theta or TV cos theta. Okay, this is a formula. Now constraint motions, example 1 and example 1. For example, here this is a rigid wall, rigid vertical wall, this is a surface. Okay, surface. So this one string, this one here string, this is a block, this one here block. Okay, this is block placed on the surface, mass of the block area m1, this one. Okay, this fixed at the rigid wall. Okay, The tension in the string here, tension in the string T, here a tension in the string here T. The mass of the block M. This connected to another block here M2. Another block here M2. Okay. This is a pulley. This one here pulley. Frictionless pulley. Now find out the here. Find the axial velocities and accelerations. Accelerations of the blocks. Okay, of the blocks. These two blocks. Find out the acceleration here v1, velocities v1, v2 and a1, a2. Find out the velocity of these two blocks and acceleration of these two blocks. How to solve this type of problems? Now, yeah, very simple. Okay. Now, M2 block moving downward direction with acceleration, for example, v2. Sorry, with velocity v2 and acceleration a2. This is a moving downward direction. The tension in the string, first of all, this is a tension T, this tension in the string here 2T, this one here 2T, this also here 2T. Okay, this moving downward direction, this one here moving downward direction, this one moving forward direction with velocity v1, with velocity here v1, acceleration a1, this is a moving same direction. Now the net power of this system is 0. The net power of this system is equal to 0. The net power means here summation P is equal to 0. That means here P1 plus here P2 is equal to 0. Here these two powers, P1 is a power of the block M1, P2 power of the block M2. So net summation P is equal to 0, P1 plus P2 is equal to 0. Now first of all, in this case block M1 moving with velocity v1 and acceleration a1 forward direction. The tension force also same direction. In this case here, velocity v1 and tension force same direction. M1 block. So here theta is equal to 0 degrees. Theta is equal to here 0 degrees. So P1 is equal to, according to this formula, tension and here tension here T, velocity v1 cos 0 degrees, cos 0, that is equal to T v1, cos 0 is equal to 1, that is equal to P1 is equal to here, P1 is equal to T v1. Okay, in this case this M2 block moving downwards the direction, so with velocity v2, acceleration a2, tension in the string here upward direction. In this case the tension force and velocity both are in opposite direction. That means here theta is equal to 180 degrees. So here this formula P2 is equal to here tension in the string here 2T and velocity of the block here v2 and cos here theta is equal to 180 degrees. Theta is equal to here 180 degrees. That is equal to here P is equal to P2 is equal to 2T v2, cos 180 is equal to minus 1, cos 180 is equal to here minus 1. So simplifies P2 is equal to here minus 2T v2. This is for example equation 1, this equation 2. Okay, equation 1 and 2 substituting here, this one and this one substituting here equation. Okay, P1 plus P2. So P1 is equal to here T v1 plus P2 is equal to minus 2T v2 is equal to 0. Okay, now this taken right side simplifies here T v1 is equal to the positive and negative values here minus positive values, so 2TT v2. Okay, TT get cancelled, simplifies here v1 is equal to 2 v2. This is the velocity of the block M1 and velocity of the block v2 is equal to v1 by 2. This is the velocity of the block m2. This is the velocity of the block here m2. Now acceleration of the these two blocks here, acceleration of the first block a1 is equal to a2 and acceleration of the block m2 is equal to here a2 is equal to a1 by 2. This is the accelerations of the these two blocks. Okay, now note it this one. Next problem, example 2, different cases. Here different cases here. For example, this one pulley, this is the pulley, this is rigid support, this also rigid support. Okay, now the mass of the block here, for example m1, the mass of the block suspended from m2. Okay, so this is a connecting over to the two pulleys. Okay, block this one m3, this one here m3. Example 2, example here 2. Okay, now these two pulleys, frictionless two pulleys, mass m1, mass m2, mass m3. This block m3 block moving downwards direction with velocity v3, acceleration a3. This moving upward direction, velocity v2 and acceleration a2. This moving upward direction here, velocity v1, acceleration v1. Tension in the string here T, here tension in the string here T. Okay, now this tension, this also same string, this also same string T. Okay, now this tension resolved into two mutual perpendicular components. So this is a two mutual perpendicular, this divided into two mutual perpendicular components. Okay, this one for example theta, this is the theta. So vertical direction of the this T here T cos theta, this one here horizontal direction T sin theta. This one resolved into two mutual perpendicular components. Here one is here first one, second one is T cos theta, here this one here T sin theta. In this case at point O, here two forces acting horizontally opposite direction, T cos theta, T sin theta, these are in equal and opposite direction, so these are two cancelled, this sin theta is cancelled. Now vertical direction forces here two T cos theta, two forces acting vertical direction, so T cos theta, this one here T cos theta. Here downward direction for velocity of the block m3 is v3. So the tension in the string here, 2t cos theta, so velocity downward direction in this case here, tension in the force here, tension in the string here 2t cos theta upward direction, both are in opposite direction. Okay, now this one p1, for example power p1. Okay, power p1, velocity this moving upward direction. Okay, the tension force are also upward direction, both are in same direction, so theta is equal to here, theta is equal to 0 degrees. So T v1 cos 0 degrees, that is equal to tv1. This tension power p1 is equal to tv1. In the same direction, tension and velocity both are in same direction, so in this case theta is equal to 0 degrees. So here p2 is equal to, here tension in the string T, only T into v2 cos theta, theta is equal to 0 degrees, T v2 cos 0 is equal to 1. So p2 is equal to here, p2 is equal to T v2. So in this case here, in this case upward direction 2t cos theta and downward direction here v3, both are in opposite direction, so theta is equal to in this case here 180 degrees. In this case here 180 degrees. So P3 is equal to 180 is equal to cos 180 is equal to 1 minus 1. So here tension 2t V3 minus here 1. So P3 is equal to minus 2t V3. This is a M3 block. So 1, 2, 3. These three net power is equal to 0. According to system, net power is equal to 0. Net power means here summation P is equal to 0. Here P1 plus P2 plus P3 is equal to 0. These three equations, these three values substituting here. So after we will get here T1, T V1 plus T V2. Here this one negative values. So minus 2 T V3 is equal to 0. So simplifies this taken right side. So T common terms here V1 plus V2 is equal to 2T V3. T get cancelled. So simplifies V1 plus V2 is equal to 2 V3. V3 is equal to V1 plus V2 by 2. This is a velocity of the block, third block. So now if V1 is equal to, for example, V2, V1 is equal to V2, that is equal to, for example, V. So velocity of the block M3 V is equal to V3 is equal to here V plus V 2V by 2 is equal to 2 get cancelled, that is equal to V. So this is a, for example, case, just example, velocity of the block M1 is equal to a velocity of the block M2 is equal to ఈక్వల్ అయితే అప్పుడు ఏమవుతుందంటే V3 బ్లాక్ అనేది V3 యొక్క బ్లాక్ అనేది ఆ రెండింటి యొక్క వాటి యొక్క వేగానికి ఈక్వల్గా ఉంటుంది. ఓకే, నౌ లీవ్ ఇట్. నౌ ద యాక్సలరేషన్ ఆఫ్ ద బ్లాక్స్, ద యాక్సలరేషన్ ఆఫ్ ద బ్లాక్ A3 is equal to here A1 plus A2 by 2. This is the acceleration of the block M3. Next one, okay, note it. Here this one rigid support. Here this is a block, this is a string here. Okay, this one here block, for example M2 block. Another block over to the frictionless pull here, this one M1 block. Okay, this is a fixed. So now find out the acceleration, velocity and here velocity and accelerations, in this. So this example 3, example here 3. Now first of all write the tension in the string. So this is a tension T, this also T, this also here T plus T, 2T here, this is a 2T. Okay, now this block M2 block moving downward direction with velocity V2, acceleration A2. So M1 block moving upward direction with velocity V1 and acceleration A1. Okay, so here tension force and velocity same direction, theta is equal to 0. Here tension and, in this case tension and velocity both are in opposite direction, 2T upward direction, here V2 downward direction. Theta is equal to here, theta is equal to 180 degrees. Here power of the M1 block, P1 is equal to here tension force T and velocity V1 cos 0, cos theta is equal to 0, nothing but here TV cos 0 is equal to 1. So P1 is equal to here, P1 is equal to TV1. Next M2 block, power of the M2 block P2 is equal to here tension in the string here 2T and velocity of the block here V2, here cos 180 degrees, that is equal to cos 180 is equal to -1 minus into plus minus 2T V2. This is a P2. Okay, the net power is equal to 0 here. P1 plus P2 is equal to 0. These two values here substituting T V1 plus here minus 2T V2 is equal to 0. Okay, now T V1 is equal to 2T V2. So T get cancelled, simplifies here. V1 is equal to 2 V2. So V2 is equal to here, V2 is equal to V1 by 2. So acceleration of the block is equal to A1 by A2. This is the acceleration of the block M2. The velocity of the block M2. V2 is equal to V1 by 2. The acceleration of the block M2 is equal to here, A2 is equal to A1 by 2. Now example 4. Okay, put it. Now for example, this is a ring, this one here, a ring. Okay, this ring connected to the string over to the pulley, over to the here pulley. Okay, the block is suspended, the block is here. Okay, this change, this one, this is a block, this one here, block placed on the surface, placed on the here surface. Okay, placed on the surface. For example M1, for example the ring, mass of the ring here, mass of the ring here M2, mass of the block M1. Now this block moving forward direction with velocity V1, with velocity V1, with velocity V1. This ring moving forward direction, so with velocity here V2, with velocity V2. Tension in the string here T, this also tension in the string here T. Okay, now the angle, this T dividing into two parts, two components. One is T sin theta, this is the angle theta, this one here angle theta, this one here T cos theta, T cos theta. Example here, theta is the angle between this block to this string. Now in this case, your tension, this is a block, for example, velocity forward direction, your tension force here T backward direction. Okay, in this case here block, the ring moving forward direction and tension also forward direction, so same direction, both are in here same direction. Tension force and velocity both are same direction. Here theta is equal to here 0 degrees. So power of the P2 is equal to here T V2 cos theta. So theta is equal to 0 degrees. So T V2. This is the power of the ring. Power of the ring. Okay. Here power of the block M1 is equal to here. Both are in opposite direction. Here theta is equal to 180 degrees. Theta is equal to here 180 degrees. So power is equal to P1 is equal to T cos theta V1. Cos theta V1. So net power is equal to here, net power is equal to 0. Net power is equal to 0. P1 plus P2 is equal to 0. P1 values here both are in opposite direction. Both are in opposite direction. So negative values. This one here and negative values. So here P1 minus T cos theta V1 is equal to this one, taken right side negative values T V2. Minus minus get cancelled, T get cancelled. Okay, T get cancelled. So simplies here V2 is equal to V1 cos theta. This is a velocity of the ring. Velocity of the ring here V2 is equal to V1 cos theta. Cos theta. Acceleration of the ring here A2 is equal to A1 cos theta. Okay, this is a example for next example. Okay, for this one, next one, three blocks here, M1, M2, M3, three blocks placed on the two blocks placed on the surface, one block suspended from the string. Okay, here this is a wall, this also here wall. Okay, block of the place, block M2 placed on the wall surface, or for example M1 block placed on the surface. These two blocks here, these two blocks, okay, overcome the pulley. This also overcome the here pulley. Okay, these two strings. So this is a block M3. This one here block M3. Okay, example here 5. Example here 5. Okay, M3 block. This block moving downward direction. This block moving forward direction with velocity v1. This block moving left side, okay, with velocity v2. Okay, here tension in the string T, here tension in the string here T. Same direction here, T and T. T velocity and tension both are in same direction. Same direction in this also same direction. Theta is equal to 0 degrees. Here theta is equal to 0 degrees. Okay, this is a tension T. This is a tension T. So in this case, this one here 2T tension. 2T tension. This block moving downward direction with velocity v3 and acceleration a3. The tension force upward direction. Tension force here upward direction. So power of the block M1 P1 is equal to 0 degrees. That is equal to T v1. Here P2 is equal to 0 degrees here T v2. Here this is 180 degrees. P3 is equal to here. P3 is equal to tension force here 2T minus v3. Okay. So net power is equal to net power summation P is equal to 0. P1 plus P2 plus P3 is equal to 0. This values here, 3 values substituting here. T v1 plus T v2 plus minus, this is a minus values. So minus 2T v3 is equal to 0. This taken right side. So T v1 plus v2 is equal to 2T v3. Sorry, TT get cancelled. TT get cancelled. So simplies v1 plus v2 is equal to here v3. This is a velocity of the block M3 v3 is equal to here v1 plus v2. Next example 6. Next example here 6. Okay, notice this one. Now block here, this is a pillar, the ring fixed into the pillar. Okay, so this one connecting to string over to the pulley and connected to the block M1. Connected to the block. This M1 block placed on the surface. Placed on the surface. This moving forward direction with velocity v1. The tension force here T. Tension force here T. Tension in the string here T. This also tension T. Okay. This block moving forward direction. This string, the ring moving vertically upward direction. Vertically upward direction. Velocity with velocity here v2. For example, the mass of the ring here. For example, m2. Okay. This one moving vertical direction with velocity v2. Acceleration here a2. Upward direction. So this tension resolved into two mutual perpendicular components. Here one is T cos theta, another one is here T sin theta. This ring moving forward direction because of the tension force here, tension T cos theta. So both are in same direction. In this one here, both are in same direction. P2 is equal to here, P2 is equal to velocity v2, tension force here, tension T cos theta. Both are in same direction. So theta is equal to here, theta is equal to 0 degrees. So P2 is equal to T, sorry, okay, both are same direction, T v2 cos theta. Okay, same direction. Angle here theta, angle here same direction, angle here theta. Okay, Now P2 is equal to this here same direction, so P1 is equal to T V1. P1 is equal to T V1. So net power is equal to 0 T V1 here. In this case here, tension force T cos theta, ring is moving this one here forward direction. Okay, this both are in opposite direction, so these both are in opposite, minus plus here T cos theta V2 simplifies here this one T V1 is equal to here T V2 cos theta. T get cancelled, simplifies here velocity of the block M1 V1 is equal to here V2 cos theta, and cos theta is equal to here V1 by V2. V1 by V2. Acceleration A1 is equal to A2 cos theta, and cos theta is equal to here A1 by A2. A1 by A2. So acceleration of the blocks, the ratio of the acceleration of the blocks here A1 by A2 is equal to cos theta. The ratio of the velocities V1 by V2 is equal to cos theta. Okay, this is the next one. Example 7. Example here 7. Note this one. Next, for example, here this is a pulley, this one block, okay, M1 block, this also M2 block, okay, two blocks, these are here two blocks, this placed on the surface, this also placed on surface. For example, M1, this is a M2 M1, okay, this angle here theta 1, this angle here theta 2, this one rigid, okay. These two blocks, the tension in the string here T, this is the tension in the string here, same string, so tension in the string here T. This moving forward direction with velocity V1, this moving M2 plus this is a V2, okay, this moving velocity V1. Now here tension force resolving into T cos theta, T sin theta. This also T cos theta, T sin theta. Here horizontal direction T cos theta 1, here vertical direction T sin theta 1. In this case here horizontal direction T cos theta 2, a vertical direction here T sin theta 2, okay. This force, this body moving with velocity V1 because of the T cos theta force, T cos theta force. This body moving, in this case here velocity and T cos theta both are in opposite direction, so theta is equal to here 180 degrees. Theta is equal to 180 degrees. Opposite direction means negative power, negative. This is the same. So here P1 is equal to here V1 T cos theta 1. Here this one theta 2, P2 is equal to here velocity V2 and tension force T cos theta 2. Cos theta 2. So net power is equal to here, net power is equal to 0. P1 plus P2 is equal to 0. This two substituting here. So P1 means V1 T cos theta 1 plus this opposite direction. So negative values. This one here negative. Okay. Negative minus V2T cos theta 2 is equal to 0. So this taken right side. So simplies V1T cos theta 1 is equal to here V2T cos theta 2. So TT get cancelled, simplies V1 cos theta 1 is equal to here V2 cos theta 2. Okay. Now V1 by V2 is equal to cos theta 1 by cos theta 2. Cos theta 2. This condition. Next example number 8. Number 8. Okay. This one note it. Okay, now here next one, this is a, for example, wall, vertical wall. Okay, this one here horizontal surface. The rod placed on the inclined, the rod here inclined, this rod here inclined, this is a rod. Okay, this rod, this angle 90 degrees, this one here angle 90 degrees, this rod moving sliding. So with this one moving velocity v1, this point here moving downwards, velocity here v2. ఇది ముందు కదిలినట్టయితే ఇది ఏమవుతుందమ్మా, కిందికి వస్తుంది, వర్టికల్ వెలాసిటీ. దిస్ వన్ వర్టికల్ వెలాసిటీ, దిస్ వన్ హియర్ హారిజాంటల్ వెలాసిటీ. Okay, the angle between this one here horizontal to this inclined rod here theta. Now first of all we imagine the rod is a string. Okay, just this imagined here, rod is a string T. Okay, so this string resolved into two mutual components. This rod is this string is this rod is a string. Okay, this cos theta is equal to T cos theta, this one here T sin theta. The velocity moving forward direction along the horizontal direction, the tension force here along the horizontal direction backward, both are in opposite direction. Here P1 is equal to minus negative values T cos theta V1. Okay, now this point moving downwards, vertical downwards with velocity v2, this one theta, this one 90, this also here 90 minus theta. So this tension force dividing into two components. So one is this one, okay, vertical direction, this one here horizontal direction here T sin theta, and vertical direction T cos of 90 minus theta. Okay, that is equal to here T cos of 90 minus theta. Both are in same direction, velocity and tension force, both are in same direction, in this case opposite direction. So power of this point here v2t here cos of 90 minus theta, that is equal to here v2 cos of 90 minus theta is equal to sin theta. So p2 is equal to here this one. So net power is equal to 0. P1 plus P2 is equal to 0. And this value substituting minus T cos theta V1 is equal to plus here this is V2 T cos of 90 minus theta, that is equal to this taken is equal to 0. T cos theta V1 is equal to, taken right side, minus get cancelled, so v2t sin of theta, okay, the tt get cancelled, same place, cos theta v1 is equal to here v2 sin theta. So v1 by v2 is equal to sin theta by here cos theta, so that is equal to tan theta, So here v1 by v2 is equal to tan theta, and acceleration of the blocks here, ratio of the acceleration of the two blocks here, two ends of the rod here, a1 by a2 is equal to tan theta. Okay, this is sin of theta is equal to cos of 90 minus theta. This example. So next problem 9 or 10 or 9. Okay, 9. Note this one. Yeah, okay, note. Now example, for example, this is a inclined wall, this is a horizontal wall, this one here horizontal wall. Okay, this is a horizontal wall, this is a inclined wall. The rod placed on the inclined into rigid walls, rigid supports. This is a rod, this is a rod. Okay, this one rod, this rod inclined on the two surfaces, this inclined. Okay, the angle between horizontal to this rod here alpha. Okay, this one rod. For example, this rod imagination into string, this is a string. Okay, T. This point moving with velocity v1, this point moving downwards, velocity here v2. How to solve this type of problem? ఇలాంటి ప్రాబ్లమ్ని ఎలా సాల్వింగ్ చేస్తాం? ఓకే, వెరీ సింపుల్. ఫస్ట్ ఆఫ్ ఆల్, దిస్ వన్ డ్రా ద horizontal, this one here. Okay, this is a angle beta, for example, angle here beta, this one angle beta. Now this string trees around is two mutual components, one t here sin alpha, another one here t cos alpha. Okay, velocity opposite direction, this point. Okay, t cos alpha, this here v1, opposite direction theta is equal to here 180 degrees. So now values here negative, values of negative power is a negative. This one, this alpha, for example, the theta, this angle here theta, for example theta. Beta is equal to the exterior angle is equal to the sum of the opposite interior angles. The sum of the opposite interior angles. Here beta is a exterior angle. The beta is a beta is a exterior, leave it, angle. Here beta is equal to, exterior angle is equal to the sum of the opposite interior angles. Interior angles are alpha and theta. Alpha and here theta. So here theta is equal to beta minus alpha. Theta is equal to here beta minus alpha. This is equal to here. This is equal to, this theta is equal to beta minus alpha. Okay. Now theta is equal to beta minus alpha. Now the tension resolved into two mutual components. One is here t sin of beta minus alpha. Here another one here t sin of cos of beta minus alpha. Okay, this tension force acting downward direction. The velocity of this point here moving with velocity v2. These both are in same direction. V2 and this one here t cos of beta minus t. Both are in same direction. Theta is equal to here 0 degrees. Positive values. This is a positive values. Okay. Now P2 is equal to here. This one P2 is equal to V2 t cos of beta minus alpha, and P1 is equal to this one opposite direction minus t here V1 cos of alpha. Net power is equal to P is equal to 0. Here P1 plus P2 is equal to 0. Simplifies these two values here, substituting here V2 t cos beta minus alpha minus this one P1 is a negative values minus t v1 cos alpha is equal to 0. So this is a taken right side, simplifies v2 cos of beta minus alpha is equal to t v1 cos alpha. Okay, here tt get cancelled, simplifies here v2 cos of beta minus alpha is equal to v1 cos alpha. This is a velocity of the two ends of the rod. So here v1 by v2 is equal to v1 by v2 is equal to v1 by v2 is equal to, so cos of beta minus alpha by cos cos alpha. This is a ratio of the two ends of the rod. The ratio of velocity of two ends of the rod. So the acceleration of the these 2 points here, a1 by a2 is equal to cos of beta minus alpha by cos of alpha. This is the ratio of acceleration of the two ends of the rod. Okay. Okay, thank you. Note this one.